First, to start with, so let me just start with the topic. So let me just saying that energy. So three major forms of energy. So there are many major forms of energy. So that I'll just say that heat, sound, and light. So in this light, so you have in this light, so light can be light, you know that with the help of light, so we are able to, you can see that the vision of an object, you can see that we are able to see a object with the help of light. So this is the basic definition. Here this light, the properties of light or the phenomenon of light can be explained. Light phenomenon can be explained by two theories. The first theory is that Newton's corpuscular theory, and then quantum theory of light. So Newton's corpuscle theory and quantum theory of light. So this quantum theory of light, so here, so Newton corpuscle theory here, so with this theory, so you can ask, sir, which theory is complete? So I would say both the theories are incomplete and both the theories are complete. Yeah, okay. Because with the help of Newton's corpuscle theory, few of the phenomenon can be explained. First one, reflection. Second one, refraction. Second one, okay. First one, reflection. Second one, refraction. Then total internal reflection. So like this. So Newton corpuscle theory can be able to explain few of the theories like this, but Newton corpuscle theory is failed to explain few of the theories like interference, diffraction, and polarization. And even this quantum theory is able to explain the phenomenon of reflection, refraction, and many other things. But the Newton corpuscle theory is failed to explain the interference, diffraction, and polarization. So since it is failed to explain, I would say it is the limitations. So these are the limitations of Newton's corpuscle theory. So but instead of that also, but it is able to finally, it explains a reflections. So Newton corpuscle theory is successfully explained reflection, one second, is successfully explained reflection, okay, reflection, refraction, and total internal reflections. So that's why we should study this, we should understand this corpuscle theory. What is actually the corpuscle theory? So here, what the Newton's corpuscle theory states, that is, whenever light travels in the medium, it travels in the form of small corpuscle. So corpuscle ಅಂದ್ರೆ ಚಿಕ್ಕ ಚಿಕ್ಕ ಕಾಳುಗಳು ಅಂತ ಹೇಳ್ತೀವಲ್ಲ ಆ ಥರ. ಸೊ ಈಗ ಲೈಟ್, ಸಪೋಸ್ ಎ ಲೈಟ್, this is a light source and here is the screen. So light from here, the light source has to pass from here to here, andre the light goes in the form of small corpuscles, ಚಿಕ್ಕ ಚಿಕ್ಕ ಕಾಳುಗಳು ಇರುತ್ತಲ್ಲ ಆ ಥರ. So light goes like this. So which means to say that light is so I can say that light travels in the form of corpuscle anta. So this is the Newton's corpuscle theory. So with this, and the straight lines alle hogutte whenever the light goes. So light travels only in straight lines, and Newton assumed that light is not a wave but it is a particle. Not a wave but it is a particle. Light is not a wave but it is a particle. Okay, so now if you ask me, sir, light is particle and light is wave, both are true, no sir, or both are false? So if you ask me again, my question is, light exhibits dual property. Light exhibits dual property, which means that light acts as wave as well as particle. So light is a wave as well as particle. That's why we call this as dual nature of light. So ಈಗ light exhibits a dual property. I said that light is a wave as well as particle. So that's why we call this as light is a dual nature of light. Okay, so having said that, next, after that, so we have to understand basic phenomenon that, so reflection. So reflection anta helidre, so yesterday sir has said this, but still I'll just say that. So whenever there is an optical medium here, so when it is some silver coated here, a mirror anta ankona, so light, when it hits the mirror, it gets bounced back to the same medium. So that phenomenon is called as reflection. So what I can say, the reflection andre enanta helbodu anta helidre, reflection is simple, nothing but bouncing back of light when light to a same medium when it hits certain optical medium which are coated with silver on one side. Okay, on one side is called as reflection. So there are few laws of reflection. First law, what is that? The incident ray the incident ray comma reflected ray and normal lie on the same plane. So this is the first law of reflection. The second law of reflection andre the angle of incidence is equal to angle of reflection. So angle of incidence is equal to angle of reflection. So suppose, so this angle of incidence and angle of reflection, so we always measure with normal, so that I'll say it later. So these are the two laws of reflection. Now the second important phenomenon is refraction. So refraction anta helidre whenever light travels from one medium to another medium, it bends or it changes its original path. The phenomenon is called refraction. Is called as refraction. If the light bends towards the medium, then it is called you can say that towards the medium, then the medium is called as denser medium. Second one, if the light bends away from the towards the normal, it is not towards the medium, it is towards the away from the normal, then it is called rarer medium. So now to put into visualization, suppose you consider two mediums. So two mediums, this is the air medium and this is a water medium. Now, and this is a normal. What is it called? This is a normal. Now let me just take a simple light is traveling from this is a rarer medium, I said that, rarer medium, and this is denser medium. So how do we decide that this is a denser medium and rarer medium? I'll just say that. So now whenever this light travels, so from here it bends towards the normal. So I should not take from here. So see, angle always it should be measured with respect to normal. E angle tagondre this is wrong. So angle, this is angle of incidence I, and this is angle of refraction R. So if this bends, so now you can see that the light is bent towards the normal. So this is a rarer medium and this is a denser medium. Now let me take one more case where again this is a normal and this is a water medium, so I can call this as denser medium, and this is the air medium. Now the light goes, so light goes from denser medium to rarer medium. So what happens? it bends away from the normal. So away from the normal. So now to put into simple words, so this is R and this is I. If I is greater than R, then the second medium is called as second medium is called as denser medium. If R is greater than I, then second medium is called as rarer medium. Okay, rarer medium. Now, so there are two laws of refraction. The same one, the incident ray, refracted ray, and the point of refraction all lie in the same plane. This is first law. The second one is the sine of angle of incidence divided by sine of angle of refraction is equal to a constant called n, called as refractive index. Is the second law. So there are many things to be explained here, refractive index and all. So that I am not going to explain here because that is bit slightly out of the context here what I am going to explain. Now let me just consider the key point to take is whenever light travels from denser medium to rarer medium, it bends away from the normal. So this is the key point that I am going to take to explain new thing, that new concept, what is the intended for your syllabus. So that is, I said that suppose you take this as a normal, and here I say take this as a denser medium, and this is rarer medium. Rarer medium. Now, so now let us assume that the light is traveling from denser medium to rarer medium. So let us take this. This is the light. So this is denser medium. So rarer medium. So what happens here? Light bends away from the normal. So away from the normal means it bends like this. So this is the angle of refraction. Now again second thing. So I will just increase angle of incidence. Again further I will increase the angle of incidence. So refraction, it goes like this. Further I will increase it. Light goes like this. Further I will increase it. So what happens? At one point of time, the light completely reflects and grazes the surface. What it is called? It is called the light grazes the surface. The light grazes surface for a particular angle of incidence. Okay, so that point is called as critical angle. Critical angle. So what is critical angle? Critical angle is the particular angle for which the angle of particular angle for which the light ray grazes the surface when it travels from denser medium to rarer medium. Okay, so that angle is called as critical angle. Now further, so here is the interesting point to take out. Now what happens if the angle of incidence is greater than the critical angle? So that time, so the simple answer is, whenever the angle of incidence is greater than the critical angle, the light rays is greater than the critical angle, so that time it gets reflected to same surface, that is in the denser medium itself it gets reflected. So now that phenomenon is called as the complete light gets reflected into a same medium. So what I can say, the complete it is reflecting, so total it is reflected outside or inside, so internal. So the phenomenon happening is here reflection. The phenomenon is called as total internal reflection. So what do you mean by total internal reflection? So for an angle of whenever the light, so total internal reflection is called as the phenomenon can be explained like this or can be defined something like this: when the angle of incidence is greater than the critical angle, the light ray gets totally reflected to a same denser medium. The phenomenon is known as total internal reflection, or in short TIR. So this total internal reflection is the major application of this, or major phenomenon is now the phenomenon where we can see this is the one is mirage or mirage, you can say that. So in a hot summer days, whenever you are traveling on a highway, you can see that the image falls, you can see that image of some tree or image of some bus can be seen on the bus roadside. You can see that is because of the mirage anta. So on a hot summer days tara, cool winter days allu kuda you can see the total internal phenomenon, that is called as looming anta karitivi. So these are the practical day-to-day applications, or the day-to-day where you can see the mirage and looming. And the next, the major application of this total internal reflection is optical fibers. So as the light suggests that, so optical means light. So light, so wires where the light is carried as the information. So how does this optical fiber works in principle? Simple, just assume that this is a medium where this medium I'll just explain it in the next class, but still just general, I'll just give you a idea. This is a medium or a wire. Now your any information is converted into electrical information, converted to light. So now, light you have converted into light, and this light is allowed to enter this medium, suppose with an angle greater than critical angle. So what happens? It hits here. Again this angle is greater than critical angle, so what happens? It get total internal reflected here, total internal reflected here, total internal reflected here, total internal reflected. So it goes like this, like this. So again here the light comes out here, and again light energy is converted into electrical energy, and again you can see that whatever the information has to be sent. So this is how the optical fiber in principle works, and in details of which I'll give it in the next class. But this is the major application of this total internal reflection is optical fibers. So optical fibers works on the principle of total internal reflection. Optical fibers works on the principle of total internal reflection. Clear? Okay. So that's what the total internal reflection. So the total internal reflection, to summarize that, there are two criterion which are necessary for the total internal reflection. The first one is the light should travel from denser medium to rarer medium. The second condition is that the angle of incidence must be greater than critical angle. So these two are the criterion to have a total internal reflection. Okay. So there are many applications of total internal reflection. So where if you want to see that, just read the chapter of total, that is optics chapter of class 12. So many applications of optical fibers. To understand that optics chapter class 12 total internal reflection, you can just read it, so you will get it. So the next class we will explain what is the optical fiber and how does it actually works. I have just given the brief introduction how this optical fiber in general works, but there are many technical terms to be explained, that we will see it in the next class.